Good morning, student. This is Janardhan Reddy, working as assistant professor in the Department of CSC, Space Institute of Technology and Sciences. Today, I am going to give you a brief description on classification of data structures. Okay. Today, I am going to explain about classification of data structures. So before we are going to discuss about the classification of data structures, so first of all we need to define the data, what is data structure. So here if you see this data structure, here the name itself indicates data structure. Data structure in the sense we are going to append a structure to the data. We are going to append a structure to the data. So that means we have a data. So the data has to be arranged. Why we need to arrange? So what is the purpose? What is the purpose? So the purpose of arranging the data is in order to easy access the data and easy to trace. That means we can trace the data in a faster way. So for that purpose only we are going to append the structure to the data. So that is the definition of data structures, or we can give another definition, that is arrangement of data in a proper way. Arrangement of data in proper way. Okay, we can say these both definitions. That means either we can say that data structure is appending a structure to the data, or arrangement of data in a proper way, that is said to be a data structure. Now I am going to give the classification of data structure. That means how we are going to classify that data structures. Classification of data structures. Classification of data structures. So here initially the data structures are going to be classified into two. One is primitive data structure. Primitive data structures. And another one is non-primitive data structures. Non-primitive data structures. Non-primitive data structures. So if you see this, primitive is nothing but it's a primary. So that means these type of primary data structures, primitive data structures, are already we have seen in our C language what are the different data types we have used for different purposes, like integer. That means our basic data types are said to be the primitive data structures. So int, float, double, char, like that. That means all these primitive data types are going to be considered as primitive data structures. So that means these type of primitive data structures are going to be used in a basic level of programming. Okay, so that is the primitive data structures. And the second one is non-primitive data structures. Here non-primitive is nothing but just secondary. or somewhat high level, or somewhat high level. So that means we are going to use in a high level programming mechanisms. Okay. So these primitive, non-primitive data structures are again classified into two ways. Let me show. Here the two types of non-primitive data structures. One is linear data structures, and non-linear data structures. Non-linear data structures. I think up to now this is clear, right? Okay. Now, non-primitive data structures. Non-primitive data structures. I have already given the classification. In that, non-primitive is going to be organized into two. One is linear data structures, and second one is non-linear data structures. Non-linear data structures. Okay. Now coming to linear data structure. Linear data structure. So what is meant by linear data structures? Here again, the name itself indicates linear data structure. So that means the arrangement of data, in a linear data structure is going to be in a linear way. So that means, so here so arrangement of data will be in a linear way. Okay. So here we have a different types of linear data structures like array, stacks, queues, and linked lists. Arrays, stacks, queues, and linked list. That means in all these types of data structures, the arrangement of data is going to be in a linear way. How the arrangement of data is in a linear way, I will explain further. Now coming to non-linear data structures, again these non-linear data structures are, so as we discussed, in a linear data structures the arrangement of data will be in a linear way. Here as per the name non-linear data structure, the arrangement should not be in a non-linear way. So that means the arrangement should be in a random way. Arrangement of data should be in random way. Here the examples are trees as well as graphs. So this is the primary classification of data structures. That too, if you go for non-primitive data structures, again the non-primitive data structures are again classified into two. One is linear data structure and another one is non-linear data structure. In a linear data structure, the arrangement of data should be in a linear way. For that, linear, the examples for the linear data structures are arrays, stacks, queues, and linked lists. And coming to the non-linear data structure, there the arrangement should be in a random way. That means that should not be linear. That should not be linear. So here we have an example. We have different types of non-linear data structures. Those are trees as well as graphs. Now I am going to explain briefly about all these non-linear data structures. Okay. Now the first one, linear data structures. Linear data structures. Linear data structures. So as okay, 10, 20, 30, 40. Now we have the first linear data structure, that is arrays. In arrays, how we are going to arrange these data elements? Now I am going to show how we are going to arrange. So as we know that the array is nothing but sequential arrangement. So that means that the array is the collection of elements which are going to be arranged in a sequential manner. So that means the data is going to be arranged like this. So everyone knows that. So that means this is the index 0, 1, 2, 3. Now is it clear? So this is the way of arrangement in the arrays. That means how we are going to arrange the data in a arrays. So that means, so here the arrangement of data elements what we have, those are all going to be arranged in a proper way based upon the index 10, 20, 30, 40. So that means the arrangement is in a linear way. So that's why it is categorized under linear data structures. Okay. Now coming to the stacks. Okay. So the stack representation should be like this. So actually this is a similar to array, that means in terms of arranging the elements, but the representation of stack should be like this. That means it has one open end. It has one open end and one closed end. So here in the stack the data should be arranged in the same way as arrays, but so that the representation is somewhat different. How that means? I am going to explain with an example. 10, 20, 30, 40. Okay. So before that, now in this video I am going to explain briefly. I am going to explain in a brief manner. So that's why I am going to show how I am going to arrange the elements in a stack. In the next videos, when we go into a detail about that particular stack, I will explain along with the operations and how we are going to perform, right? Now the arrangement should be like this. Sir, how we are going, how you are arranged all these elements? I will explain clearly, but for understanding only I am giving this example. The stack arrangement should be like this. So that means here also the arrangement of data in a stack should be like this. Here also the arrangement should be in a linear way. Okay. And next, third one, queues. Third one, queues. So here the queue is a data structure which is a linear data structure. So it seems to be a two open end. That means it has two open ends. As we have seen, stack is having one open end. So which is similar to that. That means now you may ask one question, sir, actually the stack should be, that means is there any necessity to write the stack or to draw the stack representation like this only? No, we can draw the stack like this also, no problem. You can draw the stack representation should be like this. So here the representation, that means the way of drawing the diagram is It's not in that much important, but the arrangement is very, very important. We can write in any way. We can draw this diagram for representation in any way, but the arrangement should be in a linear way. Okay, like 10, 20, 30, 40 like this. Here also 10, 20, 30, 40. Now, so this is the top position. This is the top position. Here also 10, 20, 30, 40. Sir, now why you write a top? I will explain each and everything. Okay. So this is a stack representation. Now, in the same manner, I am going to explain the queue. When we see the stack representation, here we have one open end. So one open end. Actually, that means the insertion of these elements has to be done from this end only. Okay. But whereas in the queues, we have two ends, two open ends. Okay. One is front end. One is front end. And another one is back end. Technically it is going to be called as rear end. Technically it is going to be called as a rear end. Okay, here in the queue data structures, the arrangement should be same. 10, 20, briefing. So automatically I am going to explain how these elements are going to be arranged in the linked list. 10, 20, 30, 40, and 50. So, if you see all these data structures, all these linear data structures, how the diagrammatic representation is varied from data structure to data structure, but the arrangement of elements in those particular data structure is sequential. You need to remember this particular point only. You need not to bother about how the structure of that particular data structure. You need not to consider that. You need to consider and you need to remember that how the data is going to be arranged in those particular data structures. Okay. So if you observe this array, stack, queue as well as a linked list, in all these linear data structures, the arrangement of data is happened in a linear way. Okay. So that's why these four data structures are categorized under linear data structures. Okay. Now coming to non-linear data structures. Second one, non-linear data structures. Non-linear data structures. Non-linear data structures. So as I discussed earlier, non-linear. So that means the arrangement of data is in non-linear way. Non-linear way. So that means non-linear way in the sense it's a random arrangement that should not follow any specific arrangement. Okay. Now, so as we discussed, we have two types of nonlinear data structure. One is trees and second one is graphs. Okay. Now I am going to explain briefly about trees. So tree is a nonlinear data structure. Here the data should not be arranged in a linear way. So that means how the data is going to be arranged in a tree structure. For example, if you have the same elements 10, 20, 30, 40 like that. So the arrangement of these elements is in the trees is going to be represented in this way. That means the first element is going to be set as a root, and the next element is going to be fixed at the left side of the root, so that is 20, and once the left subtree is going to be finished, later on the next element will be placed at the right of the root. So then once the left and right subtrees are going to be fixed, automatically we need to go for the next level. So that means 40. So if we have a further elements like this 50, 60 like this, like this, automatically the same arrangement should be happen. So once the level is going to be finished only, then we are going to the next level. So that means 60, level 2. So in this way, the arrangement of data is going to be done in the linear data tree data structures. And second one, graph. In a graph representation, the data is going to be arranged in a random way. Like for example, 10. If you go for an example, the same example, 10, 20, 30, 40 like this. Automatically, how the arrangement of these elements in a graph data structures. So actually, as we know that a graph is a collection of vertices along with which are connected with edges. So that's why I am going to represent these elements in a graph representation like this: 10, 20, 30, 40, 50 like this. Or we can arrange as per our wish. We can, that means the graph should be in a different ways. Okay, 10, 20, 30, 40, 50. So this is another way. So that means in many different ways we are going to represent in the graph data structures. So if you see this tree as well as graph data structures, here the arrangement of those elements, arrangement of data, it should be in a random way. So there is no specific sequential order. Okay, so here in a tree data structures we are going to arrange in a levels, but here the arrangement of data should be in a random way. There is no specific order, there is no specific level of arrangement. Okay, in this way the data is going to be arranged in a nonlinear data structures. So that's why we call these trees as well as graph as a nonlinear data structures. Okay, I hope you have a brief you got a brief idea about these nonlinear data structures, and earlier we have discussed linear data structures, and at the beginning I have discussed what is data structure and classification of data structure. In the classification of data structures, we have seen that there are two types of data structures. One is the primitive data structures and non-primitive data structures. In the primitive data structures, we have seen different types of primary data types. In later on, we have when we go for non-primitive data structures, again the non-primitive data structures are again categorized into two. One is linear data structure and another one is non-linear data structure. Here in the linear data structure is again organized in a different ways, that is the arrays, stacks, queues and linked lists, and the non-linear data structures are going to be classified into two, that is the trees as well as graphs. Now I hope that you have an idea about you may have a complete idea regarding complete classification of data structures. Okay.